Hi all, welcome to the next topic of Unit 1 Instruction Cycle. Contents. Let's see the introduction to instruction cycle. What are the phases of instruction cycle and its flow chart? Coming to the introduction, so as we know, a computer program contains sequence of instructions and this program resides in the memory unit of your computer. So the program is executed through a cycle for each instruction, which means each instruction of your program goes through a cycle which we call it as an instruction cycle. In order to complete the execution of a program, the each and every instruction that is present in a program has to go through a cycle which we call it as an instruction cycle. So coming to the phases of an instruction cycle, it is divided into four phases: fetch, decode, read the effective address, and execute. So fetch, in the fetch phase, the particular instruction is fetched from the memory. Fetch an instruction from the memory. In the decode phase, the instruction will be decoded and in order to identify what type of an instruction it is, whether it is a memory reference instruction or a register reference or input output. So the particular instruction is being decoded in the decode stage. And next, read the effective address from the memory if the instruction has an indirect address. So, in order to, if whenever your instructions I bit represents an indirect address, it has to get the effective address, and that is done in case of a read the effective address. And finally, the particular instruction will be executed by the ALU. So each and every instruction that is present in the program has to go through all these phases of instruction cycle so that the program completes its execution. So upon the completion of step 4, the control will go back to step 1 to fetch, decode and execute the next instruction. Similarly, for all the instructions that are present in the program, they go through the instruction cycle. So this process will continue until a last instruction of your program, halt instruction, is encountered in your program. So we'll see each and every phase of an instruction cycle in detail. So the first phase is the fetch and decode phase. So before, as we know that there is a register called as a program counter register present in the computer. So what is a program counter? It points to the address of the instruction that need to be executed, right? It points to the first address of the next instruction that has to be executed by the CPU. But here, since our program starts, whenever your execution of your program starts initially, the PC points to the address of the first instruction initially. So the PC is loaded with the address of the first instruction, and sequence counter will be cleared to 0, and so that it starts with the, since you are starting the execution of your program initially, it starts at a timing signal T0. So after each clock pulse, your sequence counter will be incremented by 1 so that it you get the next timing signals T1, T2 and so on until the execution of the particular instruction is completed. So if you see the micro operations that are required for the fetch and decode phases, at a timing signal T0, whatever address that is pointed by the program counter, that will be loaded into the address register. So address register holds the address of the instruction that has to be fetched from the memory. So the program counter points to the address of the instruction, first instruction initially. That address has to be copied into the address register, and this is done at the timing signal T0. At timing signal T1, whatever address that is pointed by the address register that is fetched in the memory, M of AR represents the memory unit or memory of your computer is fetched to the corresponding address which is pointed by the address register. And whatever instruction is there in the particular address, that is copied into a register called instruction register. As we know, instruction register holds the instruction that is currently being executed by the CPU. So that is done at a timing signal T1. At timing signal T0, the address pointed by the program counter is loaded into the address register. At timing signal T1, Whatever address that is present in the address register that is searched in the main memory and that is searched into the memory unit, so that particular instruction that is available at particular address of the memory is copied into the instruction register. And now the program counter should point to the address of the next instruction because the current instruction is currently being executed, is in the process of execution. So program counter should point to the next instruction. That is done by making the PC incrementing it by 1, PC to PC plus 1. That is done at a timing signal T1. And timing signal T2, you are going to decode the particular instruction which is present in the instruction register. So the instruction registers opcode bits of 12 to 14. 12 to 14 bits represents the opcode bit of a particular instruction that are given as an input to a decoder. Okay, so that you will determine what is the output of a decoder, whether it is D0, D1 or so on Dn. So in order to determine what is the output of the decoder, you are giving 12 to 14 bits of your instruction as an input to a decoder, and 0 to 11 bits represents the address of the particular instruction. So that is copied into the address register, whereas 15th bit of the instruction is present in the instruction register is copied into a I flip flop. I flip flop is a flip flop which stores the bit, mode bit, right? So that is copied into the I flip flop. So all these three clock cycles represents the fetch and decode stages of the instruction cycle. In the fetch stage, sorry, at a clock cycle T0, the program counter address is copied to the address register, and at a timing signal T1, whatever address specified by the address register is searched into the memory, and the particular instruction at that particular address of the memory is copied into the instruction register, and parallelly the program counter is incremented by 1. And at a timing signal T2, the 12 to 14 bits opcode bits of the instruction register are given it as an input to a decoder to find out the output, then from D0 to D7, as well as 0 to 11 bits, the address bits of an instruction register are copied into the address register, and a 15th bit is copied into the I flip flop. So these three clock cycles represents the fetch and decode stages of your instruction cycle. So we'll see this one by one. If you see here, the timing signal T0, program counter's value is copied into the address register. So you can see this with a diagram. So how the register transfer take place. So the program counter points to the address of the instruction. So this has to be copied into the contents of the AR register. So by placing, it has to first place the information onto the bus. So whenever your selection inputs are 0, 1, 0, we place the contents of P2. We make the selection inputs as 0, 1, 0 because it is 2. The selection inputs has to be 0, 1, 0. So so that the PC gets the control of the bus. So by getting the control of the bus, it places the address onto the bus so that by enabling the load input, the particular address is copied through the bus into the AR register. Okay. So that is done at a clock cycle T0. Since only AR is connected to the address inputs of memory, the address register is transferred from PC to AR. Place the contents of PC onto the bus by making the bus selection inputs as 0, 1, 0. And transfer the contents of the bus to AR by enabling the load input. So this is what happens at the timing signal T0. Coming to the next timing signal T1, you have to enable the read input of the memory, so contents of the particular address from the memory. So when do you enable the read inputs of the memory? By enabling this read signal. So memory it doesn't contain load, it contains only read. By enabling the read signal, the address register, address which is present in the address register is given as an input to the memory units, so that particular address contents are read from the memory and it can be placed onto the bus. So from the bus, the instruction has to be copied from the memory unit into the instruction register, right? So the memory unit has to place the particular instruction onto the bus, and that is done by selecting the selection inputs S2, S1, S0 to 111 because it is 7 here. So that the memory unit gets the control of the bus. So memory unit places the information or the instruction onto the bus by selecting the selection inputs as 111 so that the instruction will be placed onto the bus so that the instruction register by enabling the load input, it takes the information from the instruction from the bus and keep it into its own register, which is instruction register. So this is what happens, and also we need to increment the value of the program counter. By enabling the INR input, the program counter can be incremented by 1. So see, place the contents of memory. First, we have to enable the read input of memory in order to read the contents of the memory corresponding to the particular address which is stored in the address register. And you need to place the contents of the memory onto the bus by making the selection inputs as S2, S1, S0 as 111 and transfer the contents of the bus to the instruction register by enabling the load input and increment the PC. How do you increment the PC value of program counter? By enabling the INR input of the program counter so that it will be incremented by 1. So this what happens at a timing signal T1. At a timing signal T2, the opcode in the instruction register is decoded. The 12 to 14 bits, as we have seen the instruction format, it is a 16-bit format for every instruction, where 0 to 11 bits represents the address part, 12 to 14 bit represents the opcode or the operation part, and the 15th bit represents the mode bit, whether it is a direct addressing or indirect addressing. So the 12 to 14 bits, we have to identify what type of an operation has to be performed, right? For that, the 12 to 14 bits has to be given as an input to a decoder. So the decoder will find out what is output from D0 to D7. So that for that we need to copy this to a decoder. Give it as an input to a decoder, as well as 0 to 11 bits have to be copied into the address register, and the 15th bit has to be copied into a flip flop I. That happens in a timing signal T2. So with this we have seen what fetch and decode phases. Next, so what happens now? You have given the opcode as an input to a decoder. So the decoder has to identify what type of an instruction it is. What is the decoder output from D0 to D7? So the timing signal that is active after decoding is the timing signal T3. So during the timing signal T3, the control unit will determine what type of an instruction, what is the type of an instruction which is read from the memory, whether it is a memory reference instruction or a register reference instruction or an input output instruction. How do you determine what type of an instruction it is? Based on the output of the decoder. We have already seen how do you identify what type of an instruction it is. Based on the output of the decoder, the so opcode, if the opcode lies between 000 to 110, irrespective of the mode bit, we say that the particular instruction is the memory reference instruction. If the opcode lies between 111 and if the mode bit is 0, we call that particular instruction as a register reference. And if the opcode is 111 but the mode bit is 1, we classify that a particular instruction is a input output instruction. So at a timing signal T3, the control unit is going to determine what type of an instruction it is. So if the decoder output is D7, D7 is 1, then it can be either a register reference instruction or input output instruction depending upon the I bit. If the D7 is 0, which means the decoder output is not D7, it means it might be between D0 to D6. What is D0 to D6? D0 to D6 means they are memory reference instructions, right? So if the value lies between 000 to 110, which means D0 to D6, it specifies a memory reference instruction. Whenever it is a memory reference instruction, if I bit is 0, which means it is a direct address, we need not have to do anything. The effective address is already in the address register, so it starts its execution. If it is I bit is 1 in case of memory reference, it will get the effective address and it will perform a execution of the particular instruction. So that's what happens. And if the decoder output is D7, which means if a register reference or input output instruction, if it is, then it starts its execution at a timing signal T3. Once it determines that it is a register reference or input output instruction. Only in case of memory reference instruction, depending upon the I bit, it takes one more clock cycles to complete the to find out the effective address. After the instruction is completed, execution is completed, so the sequence counter will be cleared to 0, and for the next instruction it starts the fetch phase and the timing signal starts from T0. So for each and every instruction that is present in your program, it has to go through all these steps T0, T1, T2, T3. So this is called as an instruction cycle. So if you see this, this is a representation of instruction cycle in the form of a flow chart. So initially the sequence counter is 0. At a timing signal T1, the PC value is copied into the address register. The timing signal T1, so the whatever contents are there at the address which is specified by the contents of the address register are copied into the instruction register. Means the instruction which is residing at the particular address of the memory is copied into the instruction register and PC value is incremented by 1. And in the timing signal T2, you are going to decode the opcode bits. So you are going to decode the opcode bits and the 0 to 11 bits of address are copied into the address register and the 15th bit is copied into the I flip-flop. This happens in T2. And at so after that, in the decode phase itself, we are going to determine what is the output of a decoder. D7. Based on D7, you are going to identify what is the output of a decoder. If the D7 is 1, which means the decoder output is D7, then depending upon I bit, we are going to determine whether it is a input output instruction or a register reference instruction. If the decoder output is D7, that is if it is equal to 1, then based on I bit, next we are going to check I bit. If the I bit is 1, then input output instruction. If I bit is 0, then it means it is a register reference instruction. So that it executes the register reference instruction. If I bit is 0, it executes the input output instruction if I bit is 1. So after the execution of instructions is completed, it makes a sequence counter back to 0 so that it goes for fetching the next instruction according to the program order. Suppose if the decoder output is not D7, it means that it is a memory reference. You need not have to check the I bit because if the decoder output is D7 only, based on I bit, it can be an input output or register reference. But if the decoder output lies between D0 to D6, it means it is not equal to D7. That's why D7 is equal to 0. So it means it obviously means it is a memory reference instruction. So based on I bit again in memory reference, if it I is equal to 1, it means indirect address. If I is equal to 0, it means direct address. So if it is a direct address, it will not do anything in timing signal T3. It immediately executes the memory reference instruction. So if at all, if it is an indirect address, then it has to go to that particular address to get the effective address and then it executes the particular instruction. So it requires one more clock cycle T3. So in case of register reference and input output instructions, the executed clock cycle T3. So this is how, so once the effective address is calculated, it executes the particular instruction. Once the execution of a memory reference instruction is completed, the sequence counter becomes 0 again, so that the control will go back and fetch the next instruction according to the program order. So this is how an instruction, each and every instruction of your program is executed with the help of different phases of a cycle called as an instruction cycle. Thank you.